Hi, friends. Welcome to our webinar. I'm really happy to be here this afternoon and to be having one of these conversations once more. The topic for today's discussion is antimicrobial agriculture. We will be talking about soil compaction and some of the challenges that we have in agriculture. The discussion today is going to be, I think, fairly brief, and then I want to open it up for Q&A for any questions that you might have. All right. Why would I choose to speak about antimicrobial agriculture? And after all, isn't the very idea of an antimicrobial the exact antithesis of what we want to talk about when we want to speak about regenerative agriculture? We use the words regenerative agriculture to describe, for me, the definition of regenerative agriculture is an agriculture that produces plants which are so healthy they are completely resistant to diseases and insects, and they transfer that immunity to the people who consume them as food. We can have a legitimate conversation about growing food as medicine. And thirdly, they regenerate soil health. They sequester carbon, build organic matter, and develop soil microbial populations while we are growing a crop. This is the definition. This is my definition and the place that I come from when I'm speaking about regenerative agriculture. And other people have used other words. There's been conversations about sustainable agriculture and ecological agriculture. Some companies speak about a biological agriculture. I think to some degree, varying degrees, all of these ideas speak to the idea that we need to have vibrant soil microbial communities. This is certainly a fairly common conversation. There's a lot of discussion around the idea of using cover crops and crop rotations and using conscious tillage, all to regenerate soil biology. But I've realized and learned over the last 3 or 4 months visiting with farms across the countryside, across the Midwest and on the West Coast, that there are a few fundamental challenges that we still have not overcome in our thinking about developing a regenerative agriculture. And so I want to speak to those today and kind of provide a bit of an earthquake, perhaps, in the regenerative agriculture space to say that we cannot have microbially active soils. We cannot have a truly regenerative agriculture until we fix some of these fundamental problems. And I think this is an important conversation because occasionally there are some who have an ideological resistance to resolving these problems, saying that we don't want to till our soils, to remove compaction as being one example of that. And the reality is that our soils today are so microbially challenged and have become so damaged that we have to consider all tools as being viable options to fix the problem. We have to be willing to do whatever it takes to get where we want to go. And so that was really the genesis for this conversation and the cause for titling this presentation, Antimicrobial Agriculture. There are some things that we are doing today, many things in fact, but a few in particular that have a pronounced antimicrobial effect, which should be the exact opposite of what we want to have as regenerative fruit and vegetable producers and growers and farmers. So in the podcast, I enjoy asking guests different questions. One of the questions that I've asked on several occasions has been, if there were a magic wand that you could wave and change one thing about agriculture, what would that be? Gary Zimmer gave me a great answer. In fact, such a good answer that I've adopted it as my own. And Gary's answer was that if he could wave a magic wand, the one thing he would do would be to eliminate all synthetic nitrogen applications and make it impossible for people to apply synthetic nitrogen. Just have it disappear completely. And I think this is such a powerful idea. And it's a very powerful idea because the synthesis of nitrogen from the air and the capacity to add that to soils and get such a tremendous crop response it was at the foundation of the Green Revolution, and it allowed us to cover up many of the damages that we were doing to soil, and it became a replacement for healthy soil management. The reason this is such a powerful idea is that if you were to eliminate all synthetic nitrogen applications, it would mean that we would be required to have a biology-centric plant nutrition. We know that biology can absorb and sequester and fix from the air 100% of all the nitrogen that a crop requires. We can grow high-yielding 300 plus bushel per acre corn crops with no applied nitrogen other than that nitrogen which comes from cover crops and from biology. And we would have a vibrant, healthy agriculture ecosystem if we didn't have any synthetic nitrogen in place at all. But this conversation is not really a conversation, and this discussion this afternoon is not really a conversation about nitrogen, but about other management practices or mismanagement practices that have an equally damaging effect to soil biology as synthetic nitrogen applications have had over the long term. The reality is that regenerative farmers and growers need to manage their microbial activity in the soil like a lab technician, which means, very simply, we need to do everything we can to have an optimal soil environment to grow as abundant biology as possible. There is this conversation that has occurred by very famous and influential microbiologists, such as Dr. Elaine Ingham, and there's others that I could mention as well, who've described that soil biology has the capacity to sequester, to release minerals that are locked up in the soil mineral matrix and make them available for plants, and that we need to apply no fertilizers at all. I've had this conversation with Gabe Brown and with Chris Nichols, and there is a growing consensus by leading regenerative growers, and what we have observed in our work at AEA as well, is that it is possible to regenerate soil biology to such a degree that we can supply 100% of a crop's nutritional requirements, depending, of course, on whether that soil has all the minerals and nutrients necessary in the geological profile. Obviously, if we have very sandy soils or soils that simply don't have nutrients present in the geological profile, then that is not going to happen. But those soils are the exception and not the standard. A technician in a laboratory will do everything he can to keep microbes in the optimum environment. And there are many consultants today who will say, and even I have said in the past, that the idea that we can have microbial activity supply 100% of a plant's requirements might work in the laboratory, but it doesn't work very well in the field. And the reason it doesn't work very well in the field is simply because we, as farm managers, do too many things to damage soil biology. We damage biological activity, and it is our responsibility and our fault that soil biology isn't capable of supplying 100% of a crop's nutritional requirements. So I want to talk about two particular pieces that we need to shift in order to have this type of microbial activity in the field on scale. We need to think about managing our soils the same way that a laboratory technician would manage a petri dish. We need to develop a perfect microbial environment, or as perfect as possible given the constraints that we have with climatic constraints, environmental constraints, etc. There are three things that biology really needs to thrive very well. They need optimum temperature and good gas exchange and water. Not a new conversation, but I think I'll offer some new perspectives that you may not have considered before. The first is temperature. So the enzymes that are present in all living systems and that are produced by biology are denatured at 105 degrees Fahrenheit. And if you have soil that is bare and the sun is shining on it during the summer throughout much of the Great Plains and the High Plains, bare soil can reach as much as 150 degrees Fahrenheit on the surface, and it can be 110 degrees Fahrenheit 3 inches deep. So you will have no biological activity happening in the top 3 inches of your soil profile when that happens, which means that you do not have any nitrogen sequestration, you don't have any microbial release of nutrients to be made available to plants in that top couple inches of the soil profile. The second piece is that we need good gas exchange. There's this conversation which keeps recurring that plant roots need oxygen and soil biology needs oxygen. And it's true that they do need oxygen, but that is really not the best characteristic, the best way to characterize what is actually happening and what's going on. Because in reality, the soil is inhaling and exhaling constantly. There's a peak curve that happens once every 24 hours, but there's also constant inhaling and exhaling and gas exchange occurring throughout the entire day. When air is inhaled into the soil, we get nitrogen in the form of N2 gas and oxygen as O2 going down into the soil. That is rapidly consumed by biology, and the biology then exhales and releases carbon dioxide back into the soil environment. And the reality is that if you were to measure the oxygen content of the soil itself, that oxygen content usually is very, very low. It's much smaller than what is present in the air because the biology rapidly consumes it. So what soils really need, more than just oxygen, is they need good gas exchange. They need to be able to breathe. You need to be able to have nitrogen and oxygen flowing into the soil and carbon dioxide flowing out of the soil for plants to absorb for the most effective and most rapid photosynthesis. CO2 is one of the biggest limiting factors for most plants in increasing photosynthesis and increasing yields. And of course, in order to have good gas exchange, this is an indirect way of saying that soils cannot be compacted, because you can't have good gas exchange when you have compacted soils. So there are far too many growers and farmers that I've observed just in the last few months that have severe compaction layers, perhaps as shallow as 4 to 6 inches deep. Growers that have been no-till for, in some cases, decades, and believe that the answer to the challenges they're facing on their farms can be best addressed by no-till. No-till is a very valuable, useful, and necessary tool. But when no-till, as it's managed or implemented on some farms, results in a compaction zone, that compaction layer needs to be removed. So if you have a compaction layer that is 4 inches deep and you have the majority of your crop residue from the surface is gone and is decomposed because you've had a lot of rainfall this last spring or whatever the case might be, what happens in some of the farms that I've been on, we have soil surface temperatures that are pushing 150 degrees Fahrenheit, and they're in the 140 to 150 range really consistently. So I know that if the surface is 150, we're at 110 inches, or we're at 110 degrees several inches deep. So now you've just removed the top 2 to 3 inches from effective microbial populations releasing nutrients. And now you have the compaction layer that, let's say for the sake of discussion, is 5 inches deep. So you've removed the top 3 inches. You have removed biology's capacity to function below those 5 inches. That means you only have a 2-inch layer where biology is capable of functioning. Do you think that 2 inches of biology is capable of supplying a crop's nutritional requirements? The answer is absolutely not. So, of course, we need to manage our soils to create an environment where biology can thrive throughout the entire soil profile. And once we get to that point, and only at that point, can we have a conversation about supplying 100% of a crop's nutritional requirements with biology? It is absolutely possible to do this. There are many farmers that are doing this on scale, but we have to address compaction, we have to address good gas exchange, and we have to make certain that soils are covered so that we don't have these very high soil temperatures. These are some of the foundational, fundamental rules. And then, of course, biology needs to have adequate water. Just like in a petri dish, soil microbial populations for abundant functioning soil biology is fundamentally a subaquatic environment. We need to have water contained within the soil aggregates and surrounding the soil aggregates because biology needs water to function and to thrive, and they can survive with less water than plants, but they will not thrive until you have abundant water. And the key to accomplishing this is to make sure that you have good soil aggregate structure. So what I'm describing as the evils of antimicrobial farming. What is antimicrobial farming is when you have bare soils that have high temperatures with no enzyme and no biological functioning in the top several inches, and then you have a compaction layer down below. We have to resolve these two issues if we want to have a conversation about truly regenerative agriculture ecosystems. So I discovered in a conversation that I had with Michael McNeil and Jerry Hatfield a few weekends ago, I was really intrigued how they described that when no-till agriculture was first introduced and the initial testing was being done, it was being widely advocated across the Midwest, there were a few fundamental rules that were considered to be absolutely critical. The first rule was that you had to remove all the compaction. It was widely described that if you wanted to be successful using no-till, you had to remove the compaction layer with iron, with equipment. You had to go out there with a subsoiler. However, you had to identify how deep your compaction layer was and get rid of it so that you had good gas exchange throughout the entire soil profile. The second rule was that you needed to avoid recreating that compaction layer and limit the traffic that you had across the field. And the third rule was that you needed to keep soils covered at all times. I'm not sure this no-till agriculture and no-till farm management and crop management was introduced before I was around. So I didn't personally experience and observe this history, but I do know for certain that there are many growers and many farms today who describe themselves as being no-till farmers, and they are biological farmers because they're not tilling anymore, and that therefore is going to solve all of their soil's microbial problems that have not addressed these issues. And it's not working on their farms, and this is why. They don't have the biological activity. They're not able to supply all the plant's nutritional requirements because they still have soil compaction. And in some cases, because of high temperature, high rainfall, whatever the context might be, they also still have bare soils. So if we want to remove soil compaction, I believe that it is imperative we have to take physical action and physical steps to remove it using iron. There are a lot of conversations today about using cover crops, using roots, not iron, to remove compaction. And that can be possible in some cases, can be very effective in some cases, but it takes time. If we want to be effective, if we have deep compaction zones, as in thick compaction zones, several inches thick, and they are shallow, less than 12 inches deep, I believe it is imperative that we fix that compaction using equipment and develop a deep enough zone that we can have good biological activity and good gas exchange and good air and water flow through that soil profile. And then once we've removed that compaction, we can use plant roots, cover crops, and crop roots and biologicals, biostimulants to keep that compaction zone from reforming and to form very strong soil aggregates. To prevent soil compaction from reoccurring, the farms that have been the most successful no-till farms for the long term are farms that are minimizing their wheel traffic using controlled traffic farming, where you have wheel tracks in the exact same location matching up with the harvesters, planters, cultivators, whatever equipment crosses that field is all following the exact same tracks. And then by also including diverse cover crops, so keeping your soils covered at all times. Many of you already know this very well, don't need to repeat myself. And then using biologicals and biostimulants to increase soil aggregation. Point number 3 is a point that I think has not been appreciated enough. We've observed in dryland farming in southwest Kansas and Nebraska that it is possible to supply all of the benefits of a cover crop using only biologicals and biostimulants. And that's a really big claim, but we've been able to get the exact same volume and quantity of nutrient release, the exact same type of soil aggregation, the exact same type of removing compaction, simply by using biologicals and biostimulants, particularly the Rejuvenate Spectrum C-Shield Fall Primer application. When that is applied in the fall and consistently, we've found that with as little as 2 applications 24 months apart, being the least application that we've observed this successfully on, you can supply 100% of a corn crop's nutrient requirements, even without a cover crop being grown at any point in those 24 months and only having the soil covered with crop residues. This is because in dry land, of course, we have limited moisture. We need to have summer fallows, etc. So it is possible to supply all of a crop's nutrient requirements and manage compaction, reduce compaction, and produce stable soil aggregates simply with biologicals and biostimulants. The food source can come from places other than from cover crops, particularly in dryland environment where we may not have enough water to grow a cover crop. Obviously, cover crops are still best and still a strong advocate for those, but in those situations where we can't grow cover crops, I believe we need to use these biologicals and biostimulants more than we have been in the past. I'm going to open it up for Q&A. If you have any questions, you can type them into the question box at the bottom. I do really enjoy the questions and answer and the exchange because I find there's a lot of good information that comes through from that. So I'm looking forward to your questions. All right, we've got one question coming through. The first question is, what is the best technique to identify a compaction layer and to determine how bad it really is? This is a good question, and there are 2 tools that I've used personally that I really like. The one that I think many are familiar with is a penetrometer, using a penetrometer to identify compaction layers from the top down. But there's actually a second tool which I prefer and I think is perhaps even more effective than a penetrometer, and that is to first dig a hole with a shovel or a post hole digger down, let's say 2 feet deep or 18 inches deep, and then take a pocket knife and insert the pocket knife into the side of the hole with your hand. Just poke it into the soil about 2 or 3 inches deep, the length of the blade, and then pull upward, pull up toward the soil surface towards you. And this is a very effective tool for measuring the bottom of the compaction layer rather than the top and identifying how deep it really is. And that's the question you really want to know. It's the penetrometer is best at identifying where the top of the compaction layer is, but the knife is the most effective at determining where the bottom of the layer is and how deep you really need to go. So as you pull that knife up towards you through the soil profile, all of a sudden you will get into this substantially harder layer. You can feel it instantly because with your arm, your hand, you're very closely connected to it, and you move up through the soil very easily, and all of a sudden, bang, there you are. It's a very, generally for most soils, you come up against it very hard, and you feel it right then and right there. So then to the second part of your question, to determine how bad the compaction layer is, I would say that generally, when we want to evaluate how difficult a compaction layer is, the key question is how difficult is it for roots to penetrate and for water to penetrate and get through it. And it varies, of course, based on soil type, clay versus sand versus silt particles. But in general, this is a broad generalization, but in general, the primary concern that you want to identify is thickness. So if you have a compaction layer that's 1 inch thick and 12 inches deep, that is something that I would consider being able to effectively remediate simply with root systems. If you grow cover crops with penetrating root systems, they should be able to get down through that and start breaking that up. And the reason that I'm saying 12 inches deep is because that means that even until you've resolved that compaction layer, you still have water being able to flow 12 inches deep. You still are able to have that microbial population, the top 12 inches of the soil profile. If that 1 inch layer is only 4 inches deep, that is not deep enough to sustain a strong microbial population. And now I would suggest we need to use steel to get rid of it. If you are 12 inches deep, but your layer is 4 inches thick, then I would again probably use steel to get rid of it, because it will take a lot longer for multiple successive cover crops to successfully penetrate that and break through it. Michael Grove asked the question, hi Michael, how do you measure the wetness of the soil at various depths to know when it has enough water? Are there references for how much water to apply each week? And Michael, the answer is that yes, there are some great resources that the NRCS has available to measure water, to do just kind of physical measurements of the soil's water holding capacity. And so I would look up, I think there's an iPhone or an Android phone app available for all smartphones called Land PKS, which helps you identify for your soil type how the soil will behave. Will it ribbon or crumble at which stages of moisture? And you can kind of develop a feel method for just using hand feel to evaluate moisture content. And there are also moisture probes that you can just insert into the soil to evaluate how much water is there. And the interesting part, of course, is that for clay soils can be at 70% of field capacity and appear dusty dry, and the crop is not able to access any water. Olivier Tassel asked the question, is there a best period during the year to remove compaction with hard iron? Olivier, this is an awesome question, and the answer is yes. The best time is when the soil is dry. When the soil is dry, obviously the equipment is going to pull harder, but the entire soil profile will fracture a lot better. So it will fracture and you will get much better aeration down deep and provide a much better environment for the biology to thrive. So it's better to do it when the soil is drier and on the dry side. And that, of course, depending on where you are, that's generally in the fall. But it can be at any time of the year as long as it is on the dry side. Joel asked the question, how do we address the effects of silt migration from surface layers to deeper layers, especially when your average rainfall is 60 plus inches? Joel, you ask challenging questions. So I don't have a good answer for that question right off the top of my mind. I would say that we know that the most effective soil circulation and soil plowing comes from earthworms, and I have read in several different places actually where earthworms will move soil particles that would tend to migrate down back up, particularly silt, because they actually use silt as grit for their gizzard. So they can certainly help move them around, but I don't know if that is enough to answer your question. So you ask a challenging question, and I don't have a good answer for you. I'm sorry that I don't have a better one. Anthony asked the question, Anthony Granatelli. Hi, Anthony. Glad to see you. With compacted soil, how often can Rejuvenate and Spectrum and Sea Shield be applied before you reach the point of diminishing returns? Is a fall application enough? Anthony, on really compacted soils and higher value crops, we have had a few growers, these were the exception, obviously not the general rule, but we've had a few growers that applied this combination of these biologics once every 3 weeks for a total of 4 applications over a 3-month period, 12-week period. And with those successive applications, 4 applications, we're able to produce soil porosity on that soil, on that farm, to a depth of 16 inches, where we removed all the compaction to a depth of 16 inches. Can that happen? Again, it's situation dependent, depending on the state of biology and the soil particle profile, etc. But I think certainly for that farm, they did not reach the point of diminishing returns with 4 applications. They were still getting increasing returns. Lloyd Spar asked the question, hi Lloyd, is a 30-inch center subsoiler enough to remove compaction? From the conversations that I have had with people who know and who've tested, who actually have experience, they say that dependent slightly on tooth design, in general, you need to go, your spacing horizontally needs to be equal to the depth vertically. So if you are subsoiling 18 inches deep, then your greatest effectiveness will be when your shanks are placed 18 inches apart. If you're going 12 inches deep, they should be 12 inches apart. There are a few growers and machinery designers, equipment designers that I have worked with who have studied this question in depth, and they say that this is a very solid rule of thumb, that the distance the shanks are apart needs to match the depth, so that if you're going 30 inches deep, then 30 inches apart is very appropriate. But if you're going shallower, putting them closer together is going to significantly improve the response that you get. Brandon Gardell has a comment. Neil Kinsey says that getting your calcium to magnesium ratios correct needs to be achieved to prevent compaction from reoccurring. He states that the base saturation should be 68% calcium and 12% magnesium. Do you recommend these same ratios and thoughts? In general, yes. Brandon, this is a very good point, and one that I missed mentioning and should have. Absolutely, when you have adequate calcium levels, they will help with clay flocculation, soil flocculation, and developing stronger aggregate structure and help to prevent compaction from reoccurring. When you have high magnesium soils, compaction occurs very readily in high magnesium soils and also reoccurs if you break it up with iron. And kind of the bottom line, this idea of balancing calcium to magnesium ratios is very important and correct. And I would typically, on the soil analysis that we do, that we look at Logan Labs, Midwest Labs primarily, but we see a lot of samples come from many different labs. And generally, we're looking at ratios somewhere 65 to 75% base saturation calcium and 12 to 18 magnesium as being in the general range of being ideal. However, it is important to remember that really good biology and cover crops can overcome high magnesium. I distinctly and very clearly remember seeing one soil analysis that had a CEC of 26 and 40% base saturation. And I looked at the farmer and I said, well, this soil must be really hard and really compacted. And he looked at me and he said, I don't think so. I went out to the farm, looked at the soil, and the soil is rich, black, mellow, absolutely no compaction. And the reason that it wasn't compacted was because he had 9% organic matter. In very high organic matter soils, he was constantly growing cover crops and really aggressive biology. So he was able to, even though his soils were very high in magnesium, he had high enough organic matter and good enough soil biology to be able to overcome that. Now, generally, it is still a very good idea to balance calcium and magnesium numbers, and I'm a very strong advocate of using gypsum or calcium sources, whatever is appropriate based on your soil profile to balance soil chemistry. Don Mills asked a follow-up question. In an environment that is completely clay soil, such as in Georgia, would you recommend adding compost, wood chips, etc. in an effort to reduce soil compaction? And the answer is yes. I think I just answered that. So organic matter certainly is the effective solution to addressing compaction issues. Ned O'Brien asked the question, what is the minimum thickness of compaction layer for the biologicals to be effective? Ned, it's a combination, as I described earlier, it's a combination of thickness and depth. The shallower the layer, the better that root systems and biology will be able to penetrate it. And of course, it also varies depending on soil type. Is it primarily clay or silt or sand? Does it have balanced calcium to magnesium ratios? Kind of a general, just from experience, I would say if it's shallower than, if the layer itself is no thicker than 3 inches, if it's less than 3 inches, and if it is between 8 and 12 inches, I would consider trying it with roots and biology. But if it is thicker than that or shallower than that, then I believe it definitely does need to be addressed with iron sooner rather than later. Question, can compaction happen on sandy soils? Is it less likely in a sandy soil? The answer is compaction can absolutely happen in a sandy soil, and I would not say that it is less likely. It can happen in a sandy soil as well as in any other soil type, and you just need to go out there, dig a hole, use a knife, measure it. Question from Andrew Johnson. Hi, Andrew. What is the best method of alleviating compaction in irrigated hay fields composed of perennial native grasses and clover? Andrew, there are a few tools that are designed to aerate soils and to reduce compaction without disturbing the crop. Those that I'm familiar with, there is the yeoman plow, developed in Australia. There's now models available here in the US as well. There is the curse buster, which I think is not widely enough known and understood. And then there is also the airway, which can be effective, but I think is a second best to the curse buster from what I have observed. So there are tools to be able to go through and aerate soil and leave the surface and leave the crop itself relatively undisturbed. So little disturbance that you can still continue to grow a crop. Those are the types of tools that I would look at. What are your thoughts on livestock integration such as grazing cover crops and the compaction issues this might cause? Have you seen cattle create compaction in the top several inches that must be removed? This is an excellent, excellent question. Thank you so much for asking this question, Mr. Anonymous, because I think it is something that, so here are my thoughts, and these are, again, just based on observation. Compaction in the top 2 to 3 inches, or perhaps even 4 inches, caused by livestock trampling is a challenge, but it is a challenge that for whatever reason, soil biology and plant root systems seem to be able to resolve really easily in by far most soil types. So if you have compaction, if you have cattle that go out and trample soil and graze it, yes, there is usually a lot of compaction that happens in the top 2 to 3 inches. In my observation, in most soils, that is not a problem. When you have very wet soils and the compaction starts going down 6 to 8 inches, or even 6 inches or deeper, that then becomes a problem if you have that compaction because your soils are too wet and you have a sacrificed feedlot or paddock or whatever. I understand that occasionally you're in a situation where that is just unavoidable and you need to do that. That then would be a situation where I would again go through with one of the tools that I mentioned just a moment ago to try to loosen and aerate that soil down a bit deeper and aid in that pasture or that hay crop in recovering faster. The question, should you apply Sea Shield and Rejuvenate while plowing, or should they be applied before and after? Well, I'm a little bit concerned about your use of the word plowing, but assuming, I'll make the assumption that that is in reference to subsoiling and this conversation that we've been having on removing compaction layers. The ideal is that it should be applied right around the time of subsoiling, either immediately. The growers who have consistently gotten the best results are actually applying the Rejuvenate Spectrum Sea Shield in front of the tractor and then coming behind with subsoils and incorporating it immediately. So that is where, on a farm scale, we've observed the biggest and most consistent responses. Joel has a follow-up question. Can ours or other biological products be applied on a subsoiler shank to help keep the slot open longer? And yes, I would say the answer is yes. And you can apply biologicals on the shank and put them into the soil, and they will generally begin improving soil aggregation and aeration right there in the slot. And it's a very effective application tool. So it's a great question, Joel. The question, GS and agronomics, in Australia, some farmers are quitting CTF under heavy clay soil because there is a lateral compaction that is appearing aside from a vertical one. How often do you require to shift the tram lines, the track lines under such conditions? I don't know, because I haven't experienced that. And so I'm not really able to give your question a good answer. But I would suggest that it may be worth exploring or asking the question, can you arrest the lateral compaction? If it's true that lateral compaction is occurring, and I can imagine that to be the case with heavy equipment on clay soils, can you arrest that lateral compaction by periodically subsoiling immediately beside the tram lines to a depth of 30 inches or so? Can we manage that zone and prevent that lateral compaction from spreading? So I think that is something that would be worth exploring and worth looking at. Quite a number of questions that have come through here, so I'm going to be moving quickly. When using residue digester in the fall, it is recommended to incorporate the residue into the soil. What is the best way to incorporate it suitable for no-till management? Stanley, this is a great question. And in our experience, when we put on an application of Rejuvenate and Spectrum and Sea Shield in the fall onto crop residue, that residue disappears fast, purely as a function of biological digestion and degradation. In fact, it degrades so fast that on some farms where we have dryland agriculture, where it's 1 year crop and then summer fallow followed by 1 year crop, I described earlier how important it is to keep soils covered, and the residue disappears so quickly that the following year we struggle with bare soil. So we've actually begun on some of our soils not putting on this application until the following fall, just before we go to the next year's crop, so that the residue doesn't disappear too quickly. So in our experience, if you have a really good microbial inoculant and biostimulant, you can put it onto residue in the fall, and it will be incorporated into the soil as a function of earthworms and biological activity in a matter of as little as 6 to 8 weeks. The majority of it can move into the soil profile without tillage. So that would be the experience that we've had that I would suggest would be an appropriate answer. Jim Martindale has a couple of questions. Hi, Jim. Have you ever observed root system development following long-term use of curse buster tillage technology? And the second question is, are you suggesting that the depth of a compacted zone is going to determine the root system response? So to answer the second question first, the depth of a compacted zone is not necessarily going to determine the root system's response. In our experience, it will determine the speed and the effectiveness at how quickly a root system will be able to penetrate the compaction zone and break it up permanently. If your compaction zone is, let's say, 8 inches deep, if it's shallower, and you have good gas exchange to that point, then generally we find that the root systems can move through it better. Again, this is partnered with applications of Rejuvenate and Spectrum, and we can see that the overall crop response and root system response is a lot faster if the root system doesn't have to move down quite as deep to begin moving through that compaction layer. And then to the first part of your question, have we observed root system development following long-term curse buster use? Not a lot, but on a few farms. I haven't been on many farms that have used it long-term, but in general, those that have used it long-term, I would say, Jim, based on the information that you have shared, is that the root systems tend to become a lot more robust, a lot deeper than in the untreated areas. Bill Casey asked the question, are there any issues with applying the fall primer in alfalfa or no-till crop fields? Does it need to rain in soon, or will the product wait for a rain to incorporate? Bill, this is an excellent question. It is optimal to wait for a rainfall or to apply it within 48 to 72 hours before rain. With that being said, we have many growers that have applied it onto bare ground without having rain shortly after, and still get good results. That's a question, let's say on a scale of 1 to 10, 10 being optimal performance, optimal results, it's going to be reined in. If you don't have that rain within, let's say, 72 to 96 hours after application, you'll still get an 8 or a 9 out of 10. Still be very effective, but not as effective as it might have been with the rainfall. Riley asked the question, when applying Spectrum to perennial crops, where it is difficult or impossible to incorporate, should the rate be increased to account for biology damage to ultraviolet radiation? You guys asked the most fascinating questions. That's a good one, Riley. The key to protect them from ultraviolet radiation is to make your spray solution black. And so we typically, we have a bit of the humicarb incorporated into the Rejuvenate product. Rejuvenate obviously makes the material dark. You can add even more humicarb if this is a concern. And the biology are smart. They will hide out behind the humic substance and carbohydrate particles once it's applied to the soil and protect themselves from ultraviolet if you give them a dark color solution that they're capable of doing that with. Jim Martindale asked the question, aren't you concerned about massive fluxes of oxygen and nitrogen resulting from a tillage operation? I'm less concerned about the gas exchange fluctuations than I am about the compaction remaining present. So if we have compaction present, then yes, tilling it is going to introduce a lot of oxygen into the soil, and it's going to result in the flush of carbon dioxide release. And in some contexts, that might be bad. Obviously, it is a concern if we're doing a lot of tillage, but if we're doing it to remove compaction, it's a necessary treatment to get the effects that we want. Another question from an apple orchard. I can see very compacted tractor tracks from years of going through with a tractor sprayer. Although not within the drip line of the trees, is this something you would still be concerned with? This is a challenging question. And I would say it probably would not be my first priority in working to rebuild biology. I would begin by rebuilding the biological profile within the drip line, within the tree row. But then over time, I would start paying attention to the compaction in the tractor tire tracks and try to get that resolved, and also between the tracks as well. Again, because to the question that came up earlier from the Australians, these tractor tracks do create lateral compaction, particularly in clay soils, as well as in vertical compaction. And I believe that's something that we need to begin addressing much better and thinking about more than we have in the past. Follow-up to the earlier question, ultraviolet. Ultraviolet won't be an issue for the biology applied without incorporation. It's my understanding from conversations that I've had with the manufacturers of the biological inoculants that as long as the spray solution is dark, as long as it's black, ultraviolet radiation is not a concern, even when it is not incorporated and just remains on the crop residue or on the surface. Joel asked a follow-up question. Since we have a lot of center pivots on these sandy soils, can we fertigate these biologicals maybe in a more timely fashion? Joel, the answer is absolutely yes. And this is actually for all of those of you who are here listening to this who do have the capacity to fertigate, putting on Rejuvenate, Spectrum, and Sea Shield in the fertigation is very powerful. It is more powerful than applying it. And I'm referring specifically to broadcast fertigation. You still get some very nice effects with drip irrigation, but it's not the same as when you broadcast fertigate. And in fact, we know that when we add this biology, one of the things that's going to happen is we get a strong flush of CO2. Yes, a lot of the residue does end up being sequestered, much more so than if you were to add nitrogen or something like that, for example, but you do get a strong flush of CO2. So we've actually begun applying these biologicals, let's say on a corn crop, for example. We start putting on the Rejuvenate, the Sea Shield, and the Spectrum at about the R2 stage, so shortly after tasseling. So our intent is to get a strong flush of CO2 into the crop released during the current crop year while we are filling grain. So you can produce a tremendous volume of sugars and produce a very high-yielding crop by putting on these biologicals in the current crop year with an overhead irrigation system. So if any of you have the capacity to do that, that's a very, very powerful management tool that will produce a significant crop response. And I think we've got 2 more questions left. Michael asked the question, do we have any experience using soil injections of Rejuvenate and Spectrum rather than surface sprays? Yes. So when you speak about soil injections, I assume you're referring to applications with on a shank of a subsoil or something like that. And yes, we have growers who have done so, and there are very good results. I've just observed generally that we tend to get better results when it's broadcast across the soil profile than when it's applied in a strip. And this has been true of drip irrigation, and it's also been true of applying it with a shank. We do still get a very nice soil and crop response, but not to the same degree as when we broadcast it. I don't fully know and understand exactly why that is, but there are some effects that are happening when it's broadcast sprayed that are bigger than when it's shanked in. And it's a big enough difference that I would actually suggest, if you are considering injecting it with equipment, how about just spraying it onto the soil ahead of the shank and then actually having it mixed in. I think your effects are actually going to be bigger with that than they will be injected into the soil profile. Andrew Johnson, we've got one last question. Andrew Johnson asked the question, will manuring and controlled grazing of rangelands be enough to break up compaction layers over time after years of continuous grazing? I would say the answer to that is yes, based on growers that I've observed who have actually done that successfully. So if you use holistic grazing or intensively managed rotational grazing with pulsing root systems and developing deeper root systems, then yes, the key qualifier being if grazing is properly managed, then yes, I believe you can break up compaction layers over time, even after you've had years of continuous grazing. So those are all the questions that have come through. I want to thank all of you for attending and participating in the conversation. I hope that you found the information useful, and we'll speak with you, if not before, then on our next webinar coming up in a month. Have happy growing, enjoy September and cooler weather. We'll talk to you soon. Thanks, everyone. Bye.